In this lesson, we're going to start where we left off from the previous lesson with this program. Now, up until now, I've shown you several example programs where basically you have multiple lines of code that do almost the exact same thing with a slight difference. Like here, we're doing the same thing as here, we've just changed the 2 to a 3. Very rarely will you encounter this in professional situations. So what I want to show you now is how you can take something that looks like this and convert it into something that is much more efficient and easier to understand. So first of all, what you need to see here is that the offset and the array index are both the same. We have 0 through 3, so there's no reason we can't create an integer that can hold that value. So let's go ahead and do that. We're going to create an integer. We're going to call it I and set it to 0. And now immediately we can change this to I. We have exactly the same thing. If we run this program, it will run exactly the same way as it did before. We still get the exact same result. Now keep in mind that I is set to 0, so this would be I plus 1, I plus 2, and I plus 3, but we don't really want to replace, we don't want to say, for example, I plus 1 here. That would actually make more confusing code. What we want is less code, and we want it to be easier to understand. So what we can do is we can create a loop and have that loop go through I multiple times and add 1 to it, so that the first time I will be 0, then it'll be 1, then 2, and 3. In fact, we can use this same line of code inside of a loop 4 times, and we'll get the same effect. Now, before I show you how to write that into a loop, let me just show you what I'm saying. So we're going to execute that line of code with I set to 0. Now, because I is set to 0 here, this is the same thing as this. Now, if we execute this line of code and then we set I to be equal to I plus 1, and then we execute this code again, set I to be I plus 1 again, and we do that 4 times, then we have done exactly the same thing. We're going to have year 0 equals my pointer plus 0. We've added 1 to it. 0 plus 1 is 1, so we have year 1 equals my pointer plus 1, plus 2, and plus 3, and we don't need this last incrementing statement. So if we run this code, you'll see that it's the exact same thing. We still get the same output that we've always had. Now what we can do is we can put this into a loop. What we'll do is we'll say that while I is less than 4, we're going to execute these 2 lines of code. That's it. And then we don't need all the rest of that. So the first time it's going to execute, I is equal to 0. So it's going to say year 0 equals my pointer plus 0. Then it's going to add 1 to I. Then it's going to be year 1 equals my pointer plus 1. Add 1 to I. Year 2, add 1 to I. Year 3, add 1 to I. And then I will not be less than 4 anymore. And then it will stop. So because we've specified that this loop is only going to occur while I is less than 4, the last time it runs will be when I is 3, which is what we want. That will run for year 0, year 1, year 2, and year 3. So if you notice here, we'll have exactly the same result. We haven't changed anything in our program. We've just changed how it's written. It's still doing the same thing. So what we can do now is we can take this line of code, and I'll show you a trick. In C and most C-like languages, when you want to increment a variable, rather than typing variable equals variable plus 1, you can simply put the variable and then plus plus. And plus plus is a way of incrementing the variable. So this is the same thing. So here we have year I equals my pointer plus I, then we add 1 to I, and then we repeat the process. So again, we're going to have exactly the same output as we had before. The only thing that we're doing here different is that we are executing this inside of a loop. But by doing it inside of a loop, we don't have to write the same line of code 4 times. We only need the line of code once, and if we had a structure that was much larger, say we had to do it 40 times, we can just simply change how many times we're going to go through the loop rather than having to write 40 different lines of code. Now before we continue, let me go ahead and show you how you would take this and expand it in order to see exactly what it's doing. So first of all, we can go ahead and set I equals 0. And now we know that we're going to be executing this instruction. And then after that instruction, we're going to increment I to be I plus 1. And we'll go ahead and put that here just to keep everything on one line. So let's go ahead and keep track of exactly what I is set to. So when we start, I is equal to 0. Then this is going to execute so long as I is less than 4. So it's going to execute 4 times. Now the next time it would execute, I would be 4, which is not less than 4, so it would not execute. So we know it's going to execute 4 times. 0, 1, 2, and 3. And then it's going to be 4, and it's not going to execute. So now what we can do is we can go ahead and set I equal to what it says on each line. So here, I is going to be 0, 1, 2, 3. And same thing here. 0, 1, 2, 3. And now we've fully expanded it. We don't need the increment statement anymore, so we can go ahead and take these out. And you see that we are left with exactly what we started with. So this and this are functionally equivalent. So anytime you notice in your code that you have a process that is repeating more or less the same way, that is a good indicator that you may be able to create a loop for that process. So here we've done that with year. Let's go ahead and do that with month. Now notice with month we have 2 values and they're not the same. We have this 0 and 1 value, and we have this 4 and 5 value. So we can go ahead and create 2 variables for this. Let's create one called j and set it to 0, and we'll create one called k and set it to 4. Now what we can do is go ahead and set this 0 to j and this 4 to k. And now if we want to, we can create a loop that just says while j is less than 2, this line of code is going to execute. And then before we end the while loop, we need to increment both j and k. And we do that like this, j++, k++. Now let's go ahead and expand this just so we see what we're doing here. So again, we're going to start by setting j equals 0 and k equals 4. Then we're going to execute this line of code. After that, we're going to increment j and k. Now we just need to keep track of what each one is. Starting out, j is 0 and k is 4. Then it's going to execute so long as j is less than 2, so that means it's going to execute while j is 0 and 1, but not while j is 2. So we'll keep track that it incremented by 1. Now we just simply set j equal to the values you see here, 0 and 1. K becomes 4 and 5. Now we don't need these incrementing statements anymore. We don't need this line. And we're back to exactly what we had before. So we can see that we created this loop correctly. So if we take out these lines of code and we just leave our loop, everything should execute correctly. Take a look. And as you see, we have exactly what we had before. Now here we're setting k equal to 4. But what I want you to notice is that when you start I at 0, and each time you increment I, as you're going through each character, first I is 0, which is this, then 1, then 2, then 3, when it is 4, it's already the first character of month. So we don't need a new variable called k to keep track of the 4, because I will already be set to 4, because I has already gone through 0, 1, 2, and 3, and in fact offset 4 is going to be the first character of the month. So rather than have a new variable called k, we can keep I and increment I, like this. And this is basically the thought process you go through when you're designing an algorithm. You think about ways to use less variables, you think about how each variable is changing, and here you can clearly see that because I is already set to 4 as we enter this loop, we can use I directly. Now let's go ahead and expand this loop. So again, we're going to start off with j equals 0, and what is I going to be set to? Well, this executes so long as I is less than 4, which means it's going to end once this incrementing statement has set I equal to 4. And at that point, this conditional will fail, which means I is equal to 4, and it will go to the end and it will proceed. So j is going to be equal to 0, and I is going to be equal to 4. Then this line of code is going to execute. And lastly, we're going to increment j and I, so we need to keep track of what j is and what I is. J starts out as 0, I starts out as 4. It's going to proceed while j is less than 2, which means again for 0 and 1. And because we're incrementing I each time, there you go. So this will be set to 0 and 1. I will be set to 4 and 5. We don't need these incrementing statements anymore, and we don't need this. And you can see that we're right back to what we started with, and that's how we know that we made that loop correctly. So we can go ahead and now do the same thing for day. Keep in mind that since I starts as 4 and increments twice, when I has left this loop, I is going to be already equal to 6. So all we need to do is create a new loop. First, let's set j equal to 0. And while j is less than 2, again, we can go ahead and execute this line of code. This will be j, and this will be I, and then we just have to remember to increment j and I. And now with 3 loops, we have proceeded to create the exact same program. So if we run this, you will see that the output is the same as it's always been. So take a look at this. What I want you to understand is that we used to have a lot of lines of code that basically did the same thing. And what we've done is we've converted it into 3 loops. Now there's a few ways we can make this more efficient. Because we're using 2 variables here, I and j, it makes sense to declare them at the top of our program, just to keep everything organized. And we should also create a comment that lets us know what we're going to be using these variables for. And now, because we've already set them to 0, we can just proceed through the program normally. And the only thing we need to remember is that once we reach this point, we need to reset j to 0 so that this will be 0 and then 1. So you should now be able to look at any of these loops, and you should be able to understand how to expand them into what they would look like if they were not loops. In the next lesson, I'll show you some ways to make this more efficient. Meanwhile, if you have any questions, feel free to ask, and I hope you enjoyed this lesson.